Let's take a look at famous CLA vocals plugin. What's the difference between these three compressor modes, push, spank and wall? Let's take a look. Here's the push mode on the maximum value. The threshold goes down. Okay. In the spank mode, it looks this way. In the wall mode, it looks like a brick wall limiter almost. If you push it harder, the threshold is even lower and the ratio is high. Okay. Hi friends, Ilya here. As I already mentioned in the previous video, I was developing an analog compressor and I wanted to have a tool to measure attack, release time, and I couldn't find the tool that could do this. The tools that I have found showed me the plots, but none of them showed me the actual attack or release time, and the same with threshold and ratio values. I decided to try to write my own plugin, and that's what I'm going to talk about in this video. This is a plugin to measure threshold and ratio. Let's take a look at it. For measuring threshold and ratio, we need two signals. The signal that came after compressor and the original test tone signal. We need to somehow make our plugin receive both of these two signals. There are a few ways of doing this. The first way is to add a quadro track and to insert plugins just one after another. The test tone plugin in threshold ratio mode. The last one is the threshold ratio measuring tool, and somewhere in between the compressor plugin itself. We can see two signals. The white line shows the original test tone signal and the blue line shows the signal after the compressor. Here you can see the threshold and ratio are measured. It works well in the most cases when the compressor doesn't change channels 3 and 4 and affects only channels 1, 2 and doesn't alter the test tone. In the plugin settings you can select which channels you are using for the test tone. For example, for mono compressor you can use right channel for the test tone and left for the compressed signal. But some plugins really affect all the channels. For such compressors we need a bit different way of setting everything up. That I'll show you right now. We add 3 stereo tracks. The first track for the test tone generator, the second track for the compressor itself, and the third track for the measuring tool. We send signal from the first track into the second track into the compressor, and from the compressor we send it to the measuring tool. If you're using VST3 version of the plugin in Cubase, you can enable the sidechain and just select in the plugin that it receives test tone via the sidechain. We have just to send the signal through the sidechain and we see the test tone signal in white and the blue is the compressed signal. If the program you're using doesn't support sidechaining or you're using VST2 version of the plugin, well, some why the sidechain doesn't work for you. You can do almost the same using the quadro channel track. I'll show you an example in Reaper, though it supports sidechaining. You see 3 tracks and the plugins that are inserted. Let's just drag the signal from the first track, the test tone, to the compressor, channels 1, 2, from the compressor into the measuring tool, also channels 1, 2. This way you see the signal is received by the plugin. But we see the test tone is missing. Okay, let's check the input. Yeah, the test tone should be on channel 3. Let's drag the test tone signal and send it to channels 3 and 4 now. You see, the signal is received. It is really easy to do it in Reaper. Well, you can do the same in Cubase. Add the 4-channel track and send the test tone signal via send into this channel. You have to open the channel settings and select the panning of sends. You see the level of sends and the panning of sends. You click and select. Not to send it to the left and right front channel, but to the rear channels 3 and 4. Here you see our test tone signal. It is received into the channel 3. Only channel 3 is enough for that. Sure, using the sidechain is easier, but whatever works for you is fine. Our signal has steps, little 1 decibel steps. Each step is a little louder, and we can see approximately when the compressor starts to compress. We can see it visually and set the manual threshold just where it looks right, somewhere about here, -20, somewhere about there. Okay, we can calculate the ratio according to the threshold. Also, we can do it manually to calculate it in any of these points. In each point the ratio is a bit different. You see 206, 2.1. When the knee starts to become soft, it is really hard to set the threshold manually. Where should I set it, here or here? It's hard to find out. The auto threshold option lets us forget about that and calculate it automatically. It calculates several values of thresholds, of ratios, and finds the most probable threshold out of all that values. The same thing with the ratio. You can select the point where to calculate the ratio. If the knee is soft, the ratio really differs a lot. But usually you don't want to think about all these ratios, you just want to see one value, and this is what the plugin does. It calculates all the ratios. It throws away all the ratios that are too far away, and it shows the usable ratios here, and it shows the latest ratio here. And after calculating all the range of ratios, it selects the most probable ratio and shows just this one value here. This way you can relax and see just one value and not mess with all the other ratios. Let's set 4 to 1, wait till the cycle ends, and in the end of cycle you see 395. Close, that's cool. The threshold is also automatically calculated very close to what we see in the compressor. By the way, not only the threshold and ratio, but also the approximate knee size is what our plugin can calculate. You see it is 10 decibels. It is difficult usually to calculate it precisely, but something to look at is really helpful sometimes. Let's set it to 0, and at the end of cycle you see the knee is 0 again, and the ratio is calculated now a bit better, and the threshold is really close to what we have set in the plugin. Cool, that's really close. As you can see, the whole cycle can take quite a long time, from -60 to 0. Each step takes 250 milliseconds. Let's make it a little shorter so the whole cycle takes less time. You see now the measuring goes faster. We can also change the minimal level. For example, if we know that our threshold is somewhere about -20 decibels, we can set the minimal level to -40 and also save some measuring time. Short step durations work well if you have a very short attack. The step duration time should be enough for the compressor to reach the full required gain reduction, so that we measure the signal at the end of the step where the signal is already fully compressed. You see, if you zoom in, this is the beginning of the step. The compressor starts to compress, and at the end of the step, when the signal is compressed, it is measured and used for calculation. If you want to see the curve that reminds of the smooth curve, threshold ratio curve, we can just visually switch to settled mode. In this mode, only the settled values, the values at the end of each step, are used for the curve, and the curve looks a little smoother. But probably seeing the real-time curve is a bit more convenient. If you have a compressor with a long attack, as I told you, you should use the step duration long enough so that your compressor reaches full gain reduction. By the way, you can use the attack release plugin to see when the signal gets static and use the appropriate value as a step duration value. The pause value in the test tone generator sets the time when there is no signal at the end of the cycle for your compressor to fully release and get ready for the new cycle. If your compressor has a long release, you should set this knob to a longer value. Many compressors add makeup gain after the compression, so just to compensate the level difference. Let's try to add manual makeup gain and see what will change. Our signal gets louder and we see that it is much more difficult now to compare these two signals. It is problematic to determine the correct threshold because the signal is shifted. Usually this shift is automatically calculated and compensated in the plugin. I disabled this feature for now just to demonstrate. Let's enable it. As you see, the plugin shows the original level of the signal in light blue, transparent, and the signal that is gain compensated is less transparent and more blue, and this signal is used for calculations. Let's take a real-world situation. We have some compressor, for example CLA3A, it adds some makeup gain. We don't know what makeup gain it adds. Our plugin automatically compares the original and test tone signals, and if they are shifted the same value for a long enough time, it supposes this is the makeup gain the compressor adds, and we can see what exactly the value of the gain shift is. We can now correctly calculate the threshold and ratio and see how it all looks. If some why the auto makeup gain calculation doesn't work well, you can switch to manual mode and enter it manually. Shift it and see, so the signals match. Now they match, okay. Even in the manual mode you can see the hint about the value of makeup gain that was calculated automatically. Surely one of the coolest features this plugin has is saving a snapshot. Let's save one, wait till the end of the cycle, and snapshot is saved. Let's take a look in our folder, snapshot tr. Let's open the HTML and take a look. Here what our snapshot looks like. The files are saved in SVG format and two curves are saved, the compensated level curve and true level curve. As our compressor adds no gain shift, no makeup gain, both of these curves are the same now. Well, take a look at our famous 1176. Let's type the name in here. It was 41, okay. It looks this way. Let's switch to 8 to 1. Let's wait till the end of the cycle. The threshold, as you see, gets higher, as it should be in 1176. The ratio affects the threshold. Let's save the snapshot and let's duplicate and enter the new name. 8 to 1, 4 to 1, 8 to 1, 12 to 1, 20 to 1. As you see, the threshold goes up when you change the ratio. I've just saved two snapshots. The blue stripe I saved as a regular snapshot and the black I saved as a reference. Let's take a look. You see, this is the blue stripe and this is the black version. They have the same settings in the plugin, but as you see, the threshold is different and the curve is different. You can view both true level curves and compensated level curves, and so the reference can also be saved as true level reference or compensated. If you want to compare true level, this is the option you should use, but really often you just want to compare the compensated signal. If you don't need the reference anymore, you can just delete it. Just like in the attack release plugin, you can enable the live mode, and for the live mode to work properly you should enable it in the plugin settings itself, and after that the snapshots are saved automatically at the end of each cycle. Here we can see live the CLA2A testing here. Let's add some peak reduction and see what we get. Okay, you see the threshold has changed. Let's wait till the image updates. When the peak reduction is added, the threshold goes down. This is what we are waiting for. Let's wait for the plot to update. Here the threshold is -42 when we set peak reduction to 80. As you can see, we can add more gain, more output gain, but theoretically, if our plugin works well, it automatically compensates the makeup gain and shows the correct values of threshold and ratio, no matter what the gain offset is. These two little marks show the knee. Here the knee starts, and here the knee ends. And this is more linear curve. What's the difference between compress and limit modes? Let's take a look. That's interesting. In the limit mode, our compressor has more ratio at first. It tries to act like a limiter. But as any analog compressor, it has limits of gain reduction it can apply, and when this limit is reached, compressor cannot add more gain reduction, and the gain reduction doesn't change anymore, it stays the same. In other plugins you can see it as well. For example, my favorite Nova. Up to some limit the compression is applied, but when it is -12 it stops, and after that gain reduction doesn't change. If you take a look at famous Waves C1 compressor, I was always wondering why the curve goes this way. Why is it not linear? Now I understand that this is probably the replication of analog compressor behavior that has some physical limitations of maximum gain reduction. Well, as you can see, this compressor scale is from 100 to 0 and we have from 60 to 0. Let's switch our plugin to -100. We have to reload it after that, insert it again. Now it's in 100 decibels range. Let's start to save snapshots. Our snapshot has already updated. We have to set the minimum level to -100 in test tone generator, and see our snapshot goes from -100 up to 0. Now we see the picture almost the same as in this plot of Waves C1. I really like to measure ratio in manual mode. This way you can easily understand how to calculate it manually when you have the grid, the lines, the cells and the dots. Our ratio is 4:1, so we measure it at -10 decibels. This is set in the plugin. The test tone signal differs from the threshold level 20 decibels, 4 cells, and the compressed signal differs only 1 cell. So 4 cells to 1 cell, this is the ratio 4:1. Let's set it 2:1. It should probably go here. Let's check it out. Right, the signal is here. Let's set it 8:1. It should be somewhere here. Let's see. That's right. Now you can see this is really easy to understand, all these plots, the things that are not really clear at first, but now this is really easy. Just like the attack release plugin, this plugin can also save data as raw data in CSV file. Use this option, save the snapshot, and in your folder snapshot tr threshold ratio data, you get the raw data CSV file. In this file you see the data just like on the plot. This is the test tone level, this is the signal after the compressor minus gain offset, this is the level relative to the threshold, the gain reduction that was applied, the ratio calculated at this point. This is the true signal level, not compensated. You can use these data, for example, to repeat the threshold ratio curve in your own compressor. For example, copy these data, paste them into online polynomial regression tool, and calculate the formula. You can round it up a bit, remove some values, and use it for your software compressor. There's a chapter on this in the manual. And a few words more how to save the snapshots for future use. Just as in the attack release plugin, you can just copy the folder, give it a name, and if you open the HTML file, you'll see that the name in the snapshot is the same as the folder name. You can copy the attack release snapshot into the same folder, and this way you can make a database of your compressor parameters. If you want to share this snapshot with someone on the internet, you can just take one SVG snapshot. It has all the data, you can edit it, enter a new snapshot name, remove the unnecessary data, open it up. You see the snapshot name and the clear picture. You can now share it online. Dear friends, that's all I wanted to tell you about this plugin. I hope you like it, hope you find it interesting and useful. This plugin is totally free. You can download it and use it for any purpose, including commercial. If you're feeling grateful and you want to give something back, I'll be glad to receive your donations, or if you wish to support any charity project, that will be a good thank you for this plugin. Wish you all the best. Till next time, bye bye.